A remarkable scientific revolution is currently unfolding, with biotechnology advancing at an astonishing pace, granting us the means to eventually exert control over biology. This progress holds the promise of eradicating deadly diseases while simultaneously giving rise to viruses more perilous than nuclear bombs, capable of devastating humanity. The question arises, what is happening? Biotechnology is permeating every aspect of our lives. It encompasses the cotton in our clothes, the vegetables we consume, even our beloved pets. Humans have become manipulators of living organisms, employing bacteria to produce insulin, seamlessly integrating prosthetics with our minds, and harnessing industrial enzymes to manufacture paper. Gene therapy has ushered in cures for once untreatable ailments, while efforts are underway to engineer climate-resistant food crops. Our mastery over biology has accelerated so rapidly that within a few weeks of the first recorded COVID-19 case, laboratories worldwide were able to deconstruct and analyze the enigmatic coronavirus. Scientists swiftly replicated its genetic material, leading to the development of a vaccine for testing within months of the pandemic's emergence, an inconceivable feat a mere decade ago. The source of this sudden progress may seem convoluted, but in essence, expensive endeavors have become affordable, and knowledge of impressive achievements has proliferated freely. The Human Genome Project, initiated in 1990, marked a significant milestone in decoding the entirety of human DNA. 13 years and $3 billion later, the project concluded, with the cost of sequencing a human genome reduced to approximately $100 million. Presently, it is an astonishing 100,000 times cheaper, priced at a mere $1,000. How has such a transformation occurred? Converting DNA into computerized data and studying it used to be a laborious process, demanding 3 years of meticulous manual labor by skilled experts. Nowadays, it can be accomplished in a mere 2 weeks through highly automated techniques. Biotechnology has evolved from being limited to exclusive, well-funded laboratories staffed by the world's foremost experts to a field accessible to hundreds of thousands of individuals. What has further expedited progress is the widespread and open sharing of information within the scientific community. Cutting-edge discoveries now take approximately a year to be replicated in labs across the globe, a few years for those with a background in biology to comprehend, and just over a decade for high school students to explore in educational settings. Envision a scenario where your local computer repair shop assembles an authentic iPhone 11 using spare components and teenagers are tasked with constructing a genuine iPhone 5 as homework, not a shoddy homemade replica but the real deal. This analogy encapsulates the current state of biotechnology, a bona fide revolution. We are witnessing an unparalleled influx of knowledge as processes become increasingly swift and cost-effective. This accelerated pace portends even more remarkable advancements for humanity, life-saving treatments, miraculous crops, and solutions to challenges that presently elude our imagination. Alas, progress possesses a dual nature. What can be harnessed for good can also be employed for nefarious purposes, whether accidentally or intentionally. Despite the myriad benefits biotechnology offers, it holds the potential to cause the deaths of millions, and in the worst-case scenario, hundreds of millions. It could surpass the destructive power of any nuclear bomb. Recent events demonstrated the rapid spread of the novel coronavirus, and we remain uncertain whether it originated naturally or as the result of an accidental leak from a lab conducting research on coronaviruses, an issue that remains a subject of scientific debate. At least 7 million individuals perished as a consequence, with the virus itself proving relatively mild for most affected individuals. However, the future may witness a change, as our actions in biotechnology could precipitate the next pandemic. Several aspects of biotechnology contribute to this potential outcome, notably the ease with which dangerous viruses can be manipulated. Thousands of scientists can now effortlessly obtain the genetic data of infectious virus samples through online platforms for experimentation. Assembling these fragments into an artificial virus in 2023 costs as much as a new car, including all the required laboratory equipment. Simultaneously, other researchers seek out viruses concealed in nature, such as those harbored by wild bats or monkeys. Undoubtedly, numerous potentially lethal pandemics remain undiscovered. Virus hunters retrieve samples to analyze whether newly found viruses are prone to spreading among humans, documenting the level of danger they pose. When a biologist discovers a novel virus, the genetic data is usually published for public consumption, as scientific journals eagerly disseminate descriptions of potentially hazardous pathogens. Some laboratories go a step further, enhancing the virulence of viruses by merging and mutating different strains to ascertain the mutations that facilitate heightened transmissibility or increased lethality. These results are also openly shared. Furthermore, synthetic DNA and equipment required to recreate these viruses are readily available for purchase online, with minimal or no surveillance measures in place. As biotechnology tools become increasingly affordable and user-friendly, and the wealth of data on dangerous viruses multiplies, it is only a matter of time until a well-intentioned scientist inadvertently distributes the blueprints for a virus equivalent to a nuclear bomb, a superbug capable of claiming millions of lives, only for someone to utilize it, whether driven by malevolence, irresponsibility, or negligence. We are creating an environment in which anyone can easily fashion a weaponized virus within the confines of their own backyard. This reality is disconcerting, as the world would plunge into an unrelenting crisis with successive pandemics emerging year after year or simultaneously, resulting in the loss of a substantial portion of the global population, unfathomable damage to civilization, and the potential undoing of centuries of progress. However, this is not the first time we have confronted such challenges, and we are far from powerless. Nuclear technology serves as a fitting example. Nuclear energy, an incredibly potent and perilous force, possesses tremendous benefits and drawbacks. Born from weapon development programs, its creators were acutely aware of the potential for their knowledge to be misused. Consequently, stringent measures were implemented to ensure the responsible handling of nuclear knowledge and restrict access to relevant technologies. Although imperfect, the outcome has been largely successful, considering the 411 nuclear power stations currently operational worldwide. Similarly, no responsible researcher would consider divulging information on transforming commonplace laboratory equipment into machinery capable of fabricating explosives on the Internet. There is no reason why we cannot adopt a comparable approach to address the hazardous aspects of biotechnology. Experts have formulated 3 essential points. Firstly, we must impede the advent of the next catastrophic pandemic by exercising control over the treatment of dangerous viruses. Treating their genetic data as an infohazard, information that poses a societal threat if carelessly shared, implies that not everyone should have unfettered access to hazardous DNA. Those who do acquire it should be subject to meticulous tracking, rendering it significantly more challenging for malicious actors to obtain sensitive materials. The next step involves preemptively identifying potential dangers by maintaining virus detection laboratories in densely populated areas. These facilities would monitor the microcosmic world, promptly alerting us to any significant rise in particular microorganisms, thus enabling swift intervention and the implementation of countermeasures. This leads us to the final step, eradication. We must establish a robust mechanism capable of neutralizing any pandemic threat before it gains a foothold. This can be achieved through the utilization of cutting-edge tools currently under development, such as nanofillers designed to extract hazards from the air we breathe or specialized UV lamps that swiftly eliminate viruses, preventing their transmission between individuals. Additionally, we must enhance our ability to expedite the development of new vaccines, surpassing. If you enjoyed it, don't forget to like and share the video. Also provide your feedback in the comment section. Please subscribe to our channel for the latest updates. Until then, stay curious.